Alright guys, so today we talked about factoring trinomials, so I wanted to make you a quick video to talk about a few of the problems, just to kind of help you walk through that process again like we did in class. Today we talked about this process where you multiply the first number A and the last number C to ultimately do what's called factoring a trinomial. Quadratic trinomials is what we're doing. So we started with how to multiply them together to understand in order to really be able to factor, you really need to understand how they multiply together, because in a way, like multiplication, division, and factoring are all kind of the same concept. And so we kind of walk through some problems using that list of steps that's in that purple box on your notes. So I want to go to the homework for a minute and remind us a little bit about how there's two types of problems. The first type of problem is significantly simpler because there is a 1 for the A value. So if you don't see the 1, that 1 is like right here, it's invisible. And so that process is going to be a little easier because you really don't need this part after a while once you really get the feel for it. And so let's kind of walk through my work here so we can kind of understand what we did and when you can bypass stuff and when you can't. So for example, there's a 1 here, and if you start by using the AC method, you're multiplying 1 times -4, which is -4. Now your goal here is to find two numbers that would multiply to be -4, but they need to add to be exactly the middle number, 3. So if you think about 2 times 2 or 4 times 1, the best combination is 4 times -1, because if you add 4 and -1, you also get 3. So those are the numbers we're going to choose. So now we're going to go back into the problem, and we're going to keep the n squared, and we're also going to keep the -4 that's in the back there. But basically we're going to replace 3, which in the notes we call it busting the B term. When you multiply them all together, you end up with 4, and the middle will go together to make 3 values in your answer. We're kind of breaking that up and going back to 4. So the first thing we want to do after we've figured out what numbers to use is we're going to replace 3n with 4n and -1n. So here they don't have variables, but you need to have variables when you write this so that they would give you 3n if you put them together. Now we're not going to put them back together because we want to do what's called group factoring. So if we looked at these first two in a group, they have something in common. They both have a factor of n. So if you pull an n off of each of these, you could distribute an n times n. There's your n squared, and n times 4, and that's your 4n. And we could also do that in the second group. The second group have -1 in common. So if you were to distribute each of these, you would get what you started with up here. Now if you do this correctly, something happens every single time. These share the same factors, n plus 4. So that's one of your final factors in your answer. And what you took out, this can be a little harder to see sometimes, what you took out is the other factor. Now you may remember from class today that it's kind of interesting that with this problem you're getting the same numbers that you get in the end. And so that can be something you notice and can move a little quicker once you understand the structure of it. But this process every time will lead you to the answer. Now that is not as smooth to take you to the final answer when there's a number in the front other than 1. So we call this one a coefficient of 1, and we call this a coefficient not of 1. So this coefficient is a 5, and we're going to start by multiplying 5 times 2, which is 10. Now they have to multiply to be 10 while adding to be 7, and so we take a moment to think about all the options for multiplying to be 10, adding to be 7, and that's 5 and 2. Both positive. So if we're using 5 and 2, we're basically going to go back in here, and instead of 7x, we're going to replace it with the two numbers we just found, 5 and 2. Now they do need to have a variable on it, and in this case x. 5x plus 2x would be 7x. But you still have the a term, you still have the c term. So once you've busted the b and you've gone to 4 numbers, let's start thinking about this in terms of grouping. Group the first two, and these both have 5x in common. If you take 5x out, you get x plus 1. And in the second grouping, if you look at these, they both have 2 in common, and look at what happens. Those are starting to repeat. Those factors of x plus 1 have shown back up in each one. So that's a sign that you're doing it correct. So that is one of your factors. And after practice, you'll see this a lot more easily. 5x plus 2 is your other factor. So the way that you know you did this correct is you could just multiply all these together to see if it's what you had to begin with. Sorry about that. So let's say you multiplied 5x times x. Well, there's your 5x squared. 5x times 1, there's your 5x. 2 times x is your 2x. And if you put those together in the very end, you'll get the 7x in the middle. And then that final step, 2 times 1, positive 2. And so it is exactly what you started with. So factoring is kind of like dividing. You're trying to find what 2 things would multiply to be what you started with. So it's easy just to check your work at the very end. So it is hard for me to do this at home sometimes because I got to use this mouse, and drawing on it can be kind of tedious and hard to read. So this one I just did with typing, which is also kind of tedious. But let's walk through one. This is another coefficient of 1. So 1 times negative 24 is my negative 24 that they need to multiply to be. And then the middle term is what they need to add to be. So I took a moment to think about that. 6 times negative 4 is the negative 24 we need to multiply to be. And 6 plus negative 4 is the 2 that they have to add to be. So like I said, because this is a coefficient of 1, you can actually just go ahead and use your answers. You can just go ahead and say, well, that needs to be a 6 and a negative 4. And the only way you're going to get n squared is if the very first step is multiplying n times n. So that's that idea of that coefficient of 1, making it a lot simpler. So let's just multiply this together and see what we get. N times n squared. Okay. N times negative 4n. 6 times n, positive 6n. 6 times negative 4, negative 24, and yes, this is good because these 2 in the middle would go together to give you that 2n, and then everything else is the same. So that's just a quick way to think about it as a way to check your work, because if it's correct, it should multiply to be what you started with, and that's a key understanding. So this one is not as easy because of this 4 here. We got to really think about the whole process. So I did 4 times 6, 24. They have to add to be negative 25. And so one thing that I was telling some people during the IXL exercise is that when these are 1 away from each other, always consider 1 as a factor. And so you need 2 negatives to multiply to be a positive, and then 2 negatives that add to be, in this case, negative 25. So you're going to take those numbers and you're basically going to replace the b term with those 2 ideas. Just make sure you put a k on it. And then we'll start thinking about group factoring. These both have 4 in common as well as k. So we're going to divide 4k off of those first 2 terms. Excuse me. And a little harder to see, this is negative k plus 6. So really all you can do is take out a negative 1. And that way it still distributes to be what you started with. But more importantly, this is repeating, because that is something that you really need to see happen. You really need to see those terms repeat like that. So in one case, you have the repeating solution, or sorry, repeating factors, which is one of your answers. And then alternately, you have 4k minus 1, and that's your other one. So you can take a moment to multiply these together, and you'll see that it's exactly what you started with. And again, that's the main idea. Can you rewrite it algebraically where it would multiply to be what you started with? So go for it. A lot of these are the similar, are very similar. You get coefficients of 1, coefficients not of 1, all the way down the page. Coefficient of 1, coefficient not of 1. Now this one, and you really want to know that GCF can show up at any time. And so this one is kind of a sneaky one right here, because basically these have x in common, and if you pull an x off of it, then you're kind of done. If you were to rewrite this, that's what factoring is, rewrite it based on multiplication. X times x is x squared, x times 1 is 1x. That's kind of over. Now if you think about it as the method, well, your c value is 0. So you got to think like, well, what multiplies to be 0 but adds to be 1? Well, that's, you know, x plus 0 x plus 1. 0 times 1 is the 0 in the back, and 0 plus 1 is the 1 in the middle. However, this right here is kind of silly to put x plus 0. There's no point in having x plus 0. That's just x. And there's no reason to group x in parentheses. You could just have x out front. And so that's the same thing as just considering GCF, greatest common factor. So there's a hint on that one. And then the very last two, really just this one, number 11, what we really want to watch out for in this one is that you want to always check for GCF first, because as the problems become a little more challenging, you want to know that you take a greatest common factor out, and then what's left can be further factored in the way that we're talking right now. So 3 is a number that goes into all of these. So I'm going to start by taking out 3. So that gives me p squared. 6 divided by 3 is 2. Now, negative 24 divided by 3 is negative 8, but this has got a 0 behind it, so this is really negative 80 if you're trying to think of it mentally. So another coefficient of 1 here. Let's think, what would multiply to be negative 80, but when you add them together you get 2? Well, numbers that end in 0, 10 comes to mind pretty quickly, and so with this one I'm thinking 8 times 10 is 80. Now I need to make one of them negative in order to multiply to be negative 80, and that's also important to get 2. So I'm thinking I need a 10 minus 8, and that could factor this. So this is p plus 10. It's kind of hard to read. I'll try to draw that again. This is p minus 8. So you still have the 3 out front, and that's still part of your answer, but the first thing we did is basically divide the 3 off of all the coefficients so that we could see something that's a little easier to factor. And what happened is it turned into a coefficient of 1 that can then factor into this way. So good luck. Bring in your questions tomorrow, and I'm going to also link the music video that me and my class did last semester that talks about GCF and the AC method. We actually watched it the very first day of class, but I'm sure you didn't really understand much of that since you've never seen this before. So give that a view and see if that makes a little more sense, and I hope you enjoy. Bye.